Hello learners and welcome to a natural sciences lesson. So today we're going to be dealing with practice questions and application questions that are based on the concept of force. So starting with our practice questions, and remember they are based on the concept of force. The first question wants us to define a force. So in science, force is defined as a push or pull. Now, remember that we cannot see a force, but you can only see the effects of the force. So, for instance, if you are pushing or pulling an object, we can't actually see the amount of force that you are applying onto the object, but we can see the effects of it. So, if you have applied a force onto an object, the object will either start moving or the object will come to a standstill. So, that means you have applied a force onto it, and the effects of it would then be determined by that object, either it being in motion or it coming to a standstill. So a force is either a push or pull. And remember that a force, it is measured in newtons. So it is measured in newtons. Which is capital letter N. Named after the famous scientist Sir Isaac Newton. Now, the question 2 says, provide the symbol for force. So the symbol for force, we do know that the symbol for force is F, capital letter F. The symbol for force is F, and the unit for force, so hence we say that it's measured in newtons. So the unit of measure for force is newtons, but the symbol for force is capital letter F. Now question 3. We need to now provide the unit in which force is measured, and we've already answered that question because we did say that force is measured in newtons, which is the capital letter N. So provide the unit in which force is measured. That is going to be capital letter N. For instance, if you are given that there's a certain amount of force, assuming that the force is 3, you're not just going to write 3, but you're going to write 3 newtons. So this now is going to be force. So you'll say F, capital letter F, is equals to 3 newtons. Symbol for force, the magnitude of the force and the unit for force. And remember, force needs to also have direction. So depending on where this force is applied, if we're applying a force into the right, then you'd say F is equals to 3 newtons to the right. So you'll say right. If it's applied to the left, 3 newtons to the left, or 3 newtons upwards, or even downwards. So a force needs to have both the magnitude and the direction. Question 4. We now need to explain what is meant by the following and provide an example of each. A balanced force. So we need to be able to explain what is meant by a balanced force. So a balanced force, those are the forces that are equal in size and opposite in direction. So the two forces or two or more forces that are equal in size, and then they always need to be in opposite direction. Say for instance, we have, that we have a block that has a mass of 3 kg. And on this block, there's a force to the right applied to it, and this force is 6 newtons. And there's also going to be another force acting in the opposite direction, also 6 newtons. Remember, for us to illustrate a force, we need to use an arrow. So the length of the arrow determines the size of the arrow, and then the arrowhead determines the direction. So because our arrowhead here is facing to the right, that then means this force is acting to the right. And this other one, it is going to the left-hand side. The arrowhead is facing the left-hand side, so that means the force is acting to the left-hand side. And because these two forces are of equal magnitude, they are going to balance each other out. That then means we've said forces that are equal in size and opposite in direction, they are said to be balanced forces. So because these two forces are equal but acting in opposite direction, there won't be any noticeable change on this 3 kg block. So this object will not move in any direction. It will not go to the left or even go to the right because the forces, the opposing forces applied to it are balancing each other out. As we have said, balanced forces do not result in any change in motion. This object will not move in any direction because the forces applied onto it are balancing each other out. So now that we have looked at what balanced forces are, we're now going to look at what are unbalanced forces. How do we then explain them? So unbalanced forces, those are now forces that are not equal in size. Remember, important, not equal in size. The balanced forces are equal in size. However, the unbalanced forces are not equal in size. So the force applied in one direction is greater than the force applied in the opposite direction. So now that means, should we have the very same block that has a mass of 3 kg, if the force applied to the right is that of, let's just draw it nicely, if that force applied to the right is, let's say now in this case, 8 newtons, but the force applied to the left is 6 newtons. Now, as you've said, the force applied in one direction is greater, so this is greater than that one. So the 8 is greater than the 6, because the one force applied in one direction is greater than the force applied in the opposite direction. So when unbalanced forces act on an object, there is a change in speed and or in direction. So if this object was stationary, that means if this object was not moving, and these two forces were applied onto this object that is not moving. When we now add these two forces, remember direction, we said that the negatives in sciences, they show direction. So if we are saying that everything going to the right is positive and everything going to the left is negative, that then means that we can substitute a -6 here. So now that is to say, when we are adding these two forces, we are going to have 8 plus -6. Then our overall answer is going to be a +2. Remember, +2. Now, looking at the directions that we have chosen, we said everything going to the right is going to be positive. And because our answer is not 0, but our answer is +2, it then means that this object will be moving to the right with a force of 2 newtons. Now remember that this 2 is going to be our F net. Remember, F net means net force or resultant force. So you can either say it's your net force or you can say it is your resultant force. Now we get the resultant force after having added 2 or more forces that are acting on the very same object. So now that means the object will now move to the right, because initially it was stationary and 2 forces were applied onto it, and those 2 forces were not balancing each other out. So because the forces were not balancing each other out, they caused a change in speed or also the direction in an object. So it was stationary, and then now it is going to be moving to the right. So the speed has changed from 0 to a certain speed. And also the direction is going to change because it wasn't going anywhere. Now it is going to be moving to the right because there's a force of 8 newtons that was applied onto it, and another force of 6 newtons applied onto it. Remember, we said the speed, actually the direction of the object will be dependent on the bigger force. So because the bigger force in this case is 8 newtons and 8 newtons is going to the right, that then means this object will also go to the right. Should it happen that this now, let's assume that the object or this force was 16 newtons. In this case, because the bigger force would be 16, it then would mean that this 3 kg block will be going to the left because the direction of the object will depend always on the force that is applied, or the greater force that is being applied onto it. In this case, it would be the 16. But the original case, it was 8 because the 8 was the bigger force. Next question. So we now need to complete the following statements. We are told that there are always something objects involved when a force is exerted. So we do know that for a force to be exerted, there needs to be two objects. One object needs to exert a force onto the other, and remember, if the force is applied onto an object, that object will apply the very same force back but in an opposite direction. If you are pushing a wall to the right, the wall is going to apply the very same force but then going to the left-hand side. So now that means there are two objects. That is going to be U, which is object A, and object B being the wall. So there's always two objects involved when a force is exerted, which then means forces therefore always act in pairs. So there's always more than one force acting on an object. So the forces therefore always act in pairs. So there's always more than one force acting on an object. If you are pulling an object, if you are pulling a certain object on a rough horizontal surface, if you are pulling an object on a rough horizontal surface going to the left-hand side, there is a force that is exerted by the surface onto the object, and that means now we're going to have two forces, the one that you applied by pulling the object and also the other force that is exerted onto the object by the surface. So there's always more than one force acting on the object. So now, before moving on to our next set of questions being the application questions, we're just going to quickly go for a short break, and I will see you just after this.